Welcome to the BIM Companion Toolkit presentation. As many of you should know by now, the precision of the AR tool is based on the precision of point clouds, which is also the entry point of site service. So to start everything off, here are some images of when RISE are capturing 3D point cloud data at their office in Stockholm. And right after a point cloud has been captured, it can be imported into the first part of the BIM Companion Toolkit that sits on the laptop that is brought out to a renovation site. And once the import is done processing, it can be viewed inside the editor. The point cloud can also be transformed in position and in rotation, and as you can see, it can also be transformed in 2 axes at the same time. And rotated. The pivot point of the entire point cloud can also be edited. This makes matching point clouds together much easier. And this is what it looks like when you open up an entire IFC file inside the BIM Companion app. The visibility of items can be turned off or on. And now we're going to create a new IFC file that will be automatically selected on the Hololens device. And now we're switching over to the Hololens device. To aid us in our mapping process, we have the sensor stick, and also an Xbox controller. As you can see, Test Street 123 is selected inside the Hololens menu. Now we're going to go up to the wall and start the scanning process. And this is of course only a short sample that can then be selected inside the Hololens menu. But before we do that, we need to load and view the appropriate point cloud for that location. One thing to note here though is that this point cloud is captured in Stockholm and the recording site is in Umeå. The different sensor values from the sensor stick are displayed as follows. Capacitance is green, inductance is red, and electricity is blue. And what you see here is a basic blend between them all. The blend can be turned on or off individually. And here is another sensor scan that is a little bit more interesting. But before we look into that, we're going to take a look at the point cloud from within the Hololens. The point cloud is selected, and as you walk around, the point cloud is streamed from the laptop in cubic chunks. And as I said before, the point cloud that is currently loaded was actually captured in Stockholm, and this is Umeå. So the location does not match perfectly with the point cloud. And now we're going to take a look at what basic geometry generation looks like. And to aid us in this, we're using the Xbox controller. The desired object type is first selected from a list of different entity types. The object is then moved, rotated and scaled until we are satisfied with it. Multiple objects can also be edited together. That was basic geometry generation. Now we're going to take a look at some more advanced ways of generating geometry that could speed up the site survey process tremendously. Our first example of this is something that we call edge geometry. It works by selecting 3 or 4 corners on an already loaded point cloud. And the corners are found by comparing surfaces on the point cloud and then checking where they intersect. When 3 or 4 corners have been selected, a geometry can be generated. This geometry can then be saved and committed and can also be seen from the app on the laptop. That was edge geometry, but we can also generate geometry using a sensor scan cloud. And this is where we come back to the more interesting sensor scan that I hinted at earlier. It works by clustering sensor values at configurable thresholds, which in this case results in beams behind the wall based on capacitance from the sensor stick. The result is only to be considered an estimation, and this estimation can then be edited as we saw previously. The result is then saved and committed and can be seen on the laptop. And as a finale, here is a preview of what the app looks like inside a HoloLens 2 device. The first thing that happens is that the user chooses a point cloud to stream from, and then some adjustments are made on its origin. The user then starts the recording with the new sensor stick. When the recording is done, it is given a name using the built-in HoloLens 2 keyboard. The recording is selected and then the workspace is entered from the menu, more specifically the cluster mode. Some values are changed and some beams are generated based on the data from the recording. The result from the cluster is added to the workspace, which acts as a middle layer before committing to the IFC file. Then the user creates a box based on values from the location-specific point cloud. We can then see the newly created box together with the cluster beams in the list that are later committed to the IFC file.